Hello again. This is 2.3 part 2. This is a little bit shorter. Basically, it's just adding on to the same lesson that we'd already done. Let me share my screen with you. All right. So to extend how to work with multi-step equations, in this case we have equations with fractions or decimals. So first I'm going to start with one with fractions. If you want to do this problem or look at how it's done in more detail, it's on page 105 in the textbook. I'm not going to show you in the textbook just to shorten this video. But anyways, I have 3x over 4 minus x over 3 equals 10. Now you may remember in a previous video that if you have one fraction, you just multiply everything by the denominator in order to get rid of it. The problem is I have two fractions here and they do not have the same denominator. For example, if this 3 here was actually 4, then if I just multiply everything by 4, then I would eliminate the fraction here, I'd eliminate the fraction here, and then instead of 10, I would have 40 because I multiplied it by 4. Okay? But I have two different ones. So what you need to find is what's called the greatest common factor. Really, any common factor would do. I'm sorry, not the greatest common factor. I believe it's the least common multiple. Those items are too similar to each other. But any common multiple will do, but the least common one is going to make it the simplest. Okay? Now, if you don't remember from fractions, let me explain this process. You simply ask the question, what is the smallest number that 4 goes into and 3 goes into? And when I'm talking about going into, I mean in like times tables, like 4, 8, 12, 16, 3, 6, 9, 12, 15, 18, and so on. Now, you can write out the times tables, but if you know your times tables well, you find that the next one is 12, okay? So, what you want to do is you simply want to multiply the entire equation by 12. Now, I'm using parentheses here so that I can actually multiply each part, okay? So it's kind of like I'm distributing into the equation. The other thing I don't actually multiply is the equal sign, okay? So 12 times 3x, so 3 times 12 is 12, 24, 36. So I have 36x divided by 4, okay? Well, that way it's going to take too long, so I'm actually not going to do it that way. Here's what I'm going to do. I'm going to eliminate the 4 because I have 12 and 4 here, so I can reduce that to 1 over 3. So 3 times 3 becomes 9. So now I have 9x. Now, if I take the same 12 and do the same thing here, I would cross out the 3. It's probably easier if I just write it like this. 12 times each part, okay? So then that would be 4, so I would have minus 4x. And then here, 12 times 10 is equal to 120. So now I have 9x minus 4x equals 120. Simplify like terms, 9x and 4x. 9x minus 4x is the same as 9 minus 4, so I have 5x equals 120. So now I divide both sides by 5 to get my answer. Okay, so let's see. I'll just do this manually here. 5 goes into 12. 2 times 5 is 10. 5 goes into 24 times. Okay, so x is equal to 24. Okay, I hope that helps. Now, let's take a look at our next problem. We have 3.5 minus 0.02x is equal to 1.24. Okay, now I want to look at my place values. I have a tenth here. I have a tenth and a hundredth, tenth and a hundredth. Okay, so the idea is in order to get rid of decimals to simplify your problem, you want to multiply it by the highest place value. Now remember, with fractions, you want to multiply it by the least common multiple, basically a number that's larger than your denominators that they both go into. Okay? With decimals, it's a similar process, but you have to go by place value because decimals are all about place value. So I have a tenth, a hundredth, and a hundredth. Okay? So what we want to do is multiply everything times 100. And that will eliminate all the decimals. So 3.5 times 100 Now remember, when you multiply by 100, you just move your decimal over a couple of, however many spaces there are zeros. So there's 2 zeros, so I move it over 2 spaces. So I have 350. I move that 2 spaces when I multiply it times 100. So then I get 2x. Instead of 1.24, I get 124. So I have 350 minus 2x is equal to 124. Now, this is a place where people sometimes mess up. You might say, okay, this is 2x minus 350, so I add 350. No, this is positive 350 minus 2x. If that's confusing, good thing to do might be to switch the order of them so it's in standard order. So I now have negative 2x plus 350, because remember, unless it says negative in front of it, that's positive, equals 124. Now this step is unnecessary. I just did it to avoid confusion, okay? Because sometimes when a number is written like this, it can be confusing. But so in this case, I have negative 2x plus 350 equals 124. Now, I know my steps. IOP, okay? Isolate by opposite operation, plus and minus first. In order to simplify. Okay, so now I have negative 2x is equal, and let me just so that it is clear in my head, I'm going to switch this and do it like a standard arithmetic problem. 4 minus 2 is 2, 3 minus 1 is 2. So I have negative 226. Now in this case, I just switched them so that my answer, so that the process I'm doing is just regular arithmetic. But I know that since the number I'm taking away has a larger absolute value, then I'm subtracting in order to get my answer, but it has a larger absolute value, so my answer is negative. So I have negative 226. Okay. Now, before we go any further, I'm going to move the camera up here as soon as I just realized I'm at the bottom of the screen. Before we go any further, I want to point out something. When you have an equation where both numbers are negative, and the next step is going to be obviously to divide, I want to remind you that the negatives will cancel out. Oops, I'm not dividing the x, I'm dividing just the 2. Negative 2 divided by negative 2 is positive 1x. Now, since this is negative and this is negative, they cancel out and become positive, so your answer is going to be positive. So 6 divided by 2 is 3, 2 divided by 2 is 1, 2 divided by 2 is 1 again. So x is equal to positive 113. Okay, I hope that helps. You can look at the lesson. It starts on page 105 and 106. I think there's a little bit of stuff on 107 to take a look at. Thank you for your time.